Hello, you are welcome to New Focused Approach to Mathematics Basic 9. This is the revised edition, and in this video, we are continuing the series of vectors. This one, we are going to look at triangular law of vectors. This lesson can be found in page 164, triangular laws of vectors. Now, before we understand triangular laws of vectors, I want us to use GeoGebra to demonstrate something. Now, I want you to observe this triangle or this series of vectors. We have vector AB, which is called U, vector BC, which is called V, and vector AC or CA, which is called W. Now, each of these vectors have been listed here. The U is 3, 3, the V is 3, negative 4, and W is negative 6, 1. Now, because these vectors come together to close or to form a loop or to do a complete loop, when we add vector A, B to vector B, C to vector C, A, then it means we come back to the original position where we started. In that case, when we add all the vectors, it should be equal to 0 because I'm at a point A traveling to point B. Then I travel to point C. Then I come back to point A. That means I've come back to the original position. So my direction has gone all around back to the original position. So when I add all the directions I've taken and the magnitude, everything, it must come back to 0. Okay, and that is true from here because if I add the vectors based on our previous lesson on addition of vectors, adding vectors, we add the x component and the y component. So 3 plus 3 here will give me 6. 6 plus negative 6 will give me 0. Then the y part to 3 plus negative 4 is negative 1. Negative 1 plus 1 is 0. I can change this vector and form the form like this, okay, and get different values. And let's see again, 8 plus negative 2 will give us 6. 6 plus negative 6 will give us 0. 4 plus negative 6 will give us negative 2. Negative 2 plus this will give us 0. It means that anytime you add vectors all round and come back to the original, you always add up to give you 0. And look at the direction A, B, look at the A, B direction, then B, C, and then C, D. You see that? Let's try another example and see. Now look at these vectors too. This one forms a quadrilateral. So A, B, look at direction of A to B, then from B to C, then C to D, then D to A. They flow in the same direction and they will come back to the original position. Let's call it A. Again, when we add all these vectors and come back to the original position, they must add up to give you 0. And again, if I add 3 plus 3 here, you can see it's 6. 6 plus negative 4 will give you negative 6 plus negative 4 will give you 2, and then 2 plus negative 2 will give you 0. Look at the y component. 2 plus negative 3 will give us negative 1. Negative 1 plus negative 3 will give us negative 4. Then negative 4 plus 4 will give us 0. And again, if I change the orientation of these vectors and I generate new kinds of vectors, or let me just put it this way. And again, you can see that vector U is 6, 1. So 6 plus 0 here will give us 6, plus negative 9 will give us negative 3. Negative 3 plus 3 will give us 0. And then again, 1 plus negative 4 will give us negative 3. Negative 3 plus 2 will give us negative 5. And negative 5 plus 5 will give us 0. And so we always add to get 0. But if at the point one particular direction go opposite, for example, I'm going A, B, B, C, C, D, and instead of going DC and DA and I get AD, then it means I have to negate that part. Let's see example. Let's look at this vector. Here we have AB and then BC. So that means if I add AB to BC is possible. But then coming to CA, it rather tend to AC, which means it becomes negative of it. But in each case, if it's negative and I come back to the A, everything must add up to give you 0. So you can see that if I add the 9, okay, the vector 9, 9, 4, if I add it to plus negative 2, negative 5, plus negative of, because instead of the CA going to, instead of the CA becoming CA, it rather became AC. So I'll negate that one as 7 negative 1. Now let's see the addition of all this. Check what will happen. 9 plus negative 2 will give us negative 7. Negative 7 plus, no, 9 plus negative 2 will give us 7. 7 plus negative 7 will give us 0 here for the S component. 4 plus negative 5 will give us negative 1. Negative 1 plus negative 1 will give us 0. Then again, we see that everything comes back to A as 0. Now take note of this very well. So in the nutshell, what we are trying to say is that if you look at the direction of this vector here, it is OA, plus look at the direction of this, OB, plus look at the direction of this one, it rather is OB instead of BO. So it will be negative of OB. All should give us 0 per what we've studied. Okay, oh sorry, this one should be AB rather. This is AB, sorry. Okay, all should give us 0. If I try to make AB the subject, look at what will happen. If I move this one to the other side, it becomes 0, sorry, OB, positive OB, then this one cross the equal sign to become OB. So this is what we call the law of addition of triangles. Anytime you add all vectors together in a triangular form, it will end up giving you 0. So the two vectors that are flowing the same direction will be addition, whilst the one that flows opposite becomes subtraction, which is the resultant of the two vectors. And so we are going to say that if I have vector A, B, okay, it can be written as vector OB minus vector OA. And that must be true because it must fulfill the triangular law of addition of vectors. Now, based on this concept, if you are given a question like this, the vertices of a triangle P, Q, and R are given below, are given as this and that. And we want to express PQ as a column vector per what you've done. That means PQ can be resolved as OQ minus OP. Okay, and OQ, because Q is a point, when you make it a vector, it becomes OQ, which can be written as 7, 5 minus P, which is 1, negative 3. When I simplify this, I'm going to have it as 7 minus 1 is 6, whilst 5 minus negative 3 will give us 8. So then the vector PQ can be written as this. Again, vector QR can be expressed as OR minus OQ. Do you get it? And so OR is R is given as negative 3, 5 minus OQ, Q is 7, 5. Okay, again, if you simplify this, we are going to have negative 10, and then 5 minus 5 will give us 0. I'm sure you can try working out for this one and you get your answer. Now, this is quite complex. I'll be happy if you can go back and start watching the video again and again and again to understand the GeoGebra demonstration, so that you'll be able to understand the farther we've been able to reach. I'm very sure this has been of great help to you to understand the triangular law of vectors. You can go ahead and solve more questions in the textbook. Thanks so much for watching.